Welcome to Waidsum Academy, the super #1 online international school in the globe. Waidsum Academy is #1 online and physical international school on the globe. So today you're welcome to this academy, and today we will be looking at mensuration part 4. Remember, we've done part 1, part 2, and part 3. Part 1 we looked at a cylinder, and we also looked at a cuboid and a cube. Our part 1 video, so you can refer back to our part 1 video if you want to see cube, cuboid, and cylinder. Part 3 we looked at arc length and area of a sector. Okay. Part 2 we looked at prism. We deal with the different types of prism. We said there is a circular prism, which is called cylinder. There is triangular prism. Okay. There's rectangular prism, which we call the cuboid. There's square prism, which we call the cube. There is hexagonal prism. There is pentagonal prism. There are all kinds and manners of prism. So we've looked at prism, and we've done the volume of prism and the surface area of the prism. So that was our part 2 video. Part 3 video extensively looked at the arc length in a circle, the arc length, and the area of the sector. You know, the two radius plus an arc form a sector. So we looked at the area and so on and so forth, and the surface area. Now today, part 4, we'll be looking at the volume of a sphere. And yes, for sphere, I think holistically we focus on the volume of a sphere, and we also probably looked at the hemisphere. Okay, in the case of hemisphere, it's just like you slide the sphere into two. We say a sphere is not just a circle. A sphere is a 3D shape, it's not a 2D shape. So we don't just call it a circle, or like you're calculating the area of a circle. No, a sphere is a 3D shape. Hence, we can calculate the volume of this 3D shape by saying that the volume of the sphere is given as 4/3 pi r cube. Why we use radius cube? You know, this is the radius of the sphere. And why we say radius cube? Because we're calculating volume. Because if we're calculating area, it would have been pi r squared. If we're calculating area, it would have been pi r squared. But because it's a volume connotation, a volume syndrome, so it's going to be pi r cube. Now, if we ask you to calculate the hemisphere, in the case of volume of hemisphere, let's change to something more dynamic. Okay. In the case of when looking at volume of hemisphere, hemisphere is characteristically means that you are going to divide the sphere into two. You're going to slide it into 2 equal half. So hemisphere, for hemisphere, okay, we say volume of hemisphere, which means half of a sphere. When we say hemisphere, we are talking about half of the square. So when we say volume of hemisphere, we are simply dividing the volume of a sphere by 2. Okay? So when we say volume of hemisphere, what we're saying is that divide the sphere by 2. So diagrammatically, is like you're going to slide the sphere. Diagrammatically, you're going to slide it to 2 equal parts. However, mathematically, we're going to look at the formula by dividing whatever you have as the volume of a sphere, which is 4/3. You know, the volume of a sphere is 4/3 pi r cube. 4/3 is a parameter that is used to measure the cube part of the volume part. So pi r cube multiplied by 4/3. Now, this is for hemisphere. You're going to divide this value by 2. Like so, if I divide this value by 2, it's like you're also saying it's same thing as saying multiplying by half. It's same thing as saying multiplying this concept by half. So multiply here by 1/2. Okay, it's same as saying divided by 2. So when you do this, these 2 at the bottom, we cancel these 4 at the top, remaining 2 here. So the formula for hemisphere will automatically be written as 2/3, because here is now remaining 2 and here is still 3. So we have for hemisphere in the exam, we should be able to come up straight away, they are saying the volume of hemisphere is 2 over 3 pi r cube. 2 over 3 pi r cube. So once you know this, then the only thing you need here is the radius. Once you give you the radius, then you'll be able to calculate either the volume of a sphere or the volume of a hemisphere. Now let's take a look at this first question. It says calculate the volume of the sphere. Give your answer to 3 significant figures. Now, I will make this as A. The B part will be the hemisphere. Calculate the volume of the hemisphere will be the B part of question number 1. So I'm not going to repeat the question. I will just put B. I'll put hemisphere. Meaning we're going to calculate volume, hemisphere. So for the B, we'll just put volume, calculate volume of the hemisphere. Volume, I write VOL of hemisphere. So volume of hemisphere is the B part of this question. Now, so we're going to look out for this now, for this mensuration in the exam questions or on anywhere we see this type of questions. How do we deal with this? So to deal with this is always to remember the formula. Always to remember all these formulas. So you need to have a list of all your mathematical formula. Okay? And you need to remember that they are very easy to remember. Okay? Very easy to remember. So for hemisphere, it's for sphere, it's 4 over 3 pi r cube. And for hemisphere, it's 2 over 3 pi r cube. So to find the volume of sphere, where the radius is 3 centimeters, just to substitute the value 3 centimeters in this formula. So if we go by that, so we have 4 over 3. We have 4 over 3 times, what's the value of pi? 3.14. Or if you like, you can put the pi straight away. 3.142 or 3.14 for simplicity, times the radius, which is given to us and is 3. And this radius, we raise it to power 3. Because from the formula, they say r cube. So we raise this radius to power 3. The mistake many students make, they will say this is 9. They will think this is 3 times 3. This is not 3 times 3. And this is never going to be 9. This is 3 in 3 places. 3 times 3 times 3, which is 27. So you're going to multiply 27 by 3.14 times 4, divide everything by 3. So what do we get? 113.1. Because they say to 3 significant figure, right? So which is eventually 113. Eventually 113. So here we get 113, 113.11. 113.11. And if we change our answer to 3 significant figure, then we will get 113 centimeter cube. Remember to always put the unit. Remember, when you solve a problem, since we are talking about volume, you're going to put the unit. So you say 113 centimeter cube as the volume of this hemisphere, of this sphere, as the volume of the sphere. So this will be our volume of sphere, 113. Okay, 113. Volume V is equal to 113 centimeter cube. So that's for the sphere. Now, using the same radius, assuming that the hemisphere is now, we now have a hemisphere, something like this. Let's say we have something like this. A hemisphere is half of the sphere. This is a hemisphere, just like a cup. Just like a cup. This is a hemisphere. And here we have, let's say we have a radius of this hemisphere to be 5 centimeters. Let's say this is a bigger one. Okay, we have the radius here from the center to the end. We have this radius to be 5 centimeters. R equals to 5. So calculate the volume of the hemisphere for this particular one. Calculate the volume of the hemisphere. So volume hemisphere, volume, so I put VH or V hemi so that you can easily relate. Volume of the hemisphere is equal to 2 over 3. Remember that. 2 over 3 pi r cube. 2 over 3 pi r cube. So we substitute our radius into this unique formula, and then we'll be able to get our volume of the hemisphere. So for sphere calculation is really easy. All we need to do is to substitute the value of the radius only into the formula. So if we do that, we have 2 over 3. We're going to have 2 over 3 times the value of pi, which is 3.14, times the value of pi, which is 3.14, times the radius, which is 5. So we're going to cube the radius. So this will be 5 raised to the power of 3. We're going to cube the radius. You must not forget that. So when we key this in a calculator, when we key it, 5 raised to power 3 is 5 times 5 times 5, which is 125. Okay? So this one is 125, 5 to the power of 3. Then divide by 3. Okay, have we done that? So we get what? We get something like 261. To three significant figure, we get 262. This will be 261.8. Okay, 0.8. So, which will invariably give us, we can key to see whether we are right while pressing the calculator. So this will give us, to three significant figure, this will give us 262 centimeter cube as the volume of the hemisphere. Remember, this hemisphere, the size was bigger than the size of this sphere. Okay, don't say, oh, why is the hemisphere value now bigger than the sphere he calculated? This sphere, the radius was just 3. The hemisphere, the radius is 5. Okay, so if we calculate for this, we will get a smaller answer. Just divide this answer by 2. If I want the hemisphere for this one, I will just divide. We will divide this answer by 2. Okay, you get 56.5. So for this hemisphere, the volume of this one, this hemisphere, will be the volume of the sphere divided by 2. So when you do that, you will get 113 divided by 2, which gives you 56.5 invariably. Okay, so this will give you or give us 56.5 centimeter cube. Okay, as the volume of this hemisphere. 56.5 centimeter cube as the volume of this hemisphere. For this, we're talking about this. If you're looking for the hemisphere, the volume of the hemisphere, okay, you see it's way smaller, 56. But for this one we did, this hemisphere, the volume is 262. If we are asked to calculate this sphere, the volume of this sphere, we can simply, okay, for this one, let's say B Roman figure 2. B Roman figure 2. Let's assume this one is B Roman figure 1. This is B Roman figure 1. So B Roman figure 2 here, if you are asked to calculate the volume of the sphere that has 5 centimeters, so the volume of sphere, V sphere, is equal to, we already have the volume of the hemisphere, so we can simply, in order not to go through the rigorous multiplication or rigorous substitution, we just say 262 multiplied by 2. Because hemisphere, if you want the sphere, if you already have the hemisphere with same radius, if you want the sphere, you just multiply the answer by 2. So you get what? 524. So this will be the volume of this sphere that has 5 centimeter radius. 524 centimeter cube. 524 centimeter cube. That will be the volume of this sphere with radius 5 centimeters. Is that okay? So that's that for that. Now let's go to another question. In this question, we have A and B. Sphere A has a radius of 8 centimeters and sphere B has a radius of 16 centimeters. Okay, question number 2. Sphere A has a radius of 8 centimeters, sphere B has a radius of 16 centimeters. Calculate the ratio of their surface area in the form of 1 to n. Calculate the ratio of their surface area in the form of 1 to n. Okay, so So the first thing we do is that the sphere A has a radius of 8 centimeter and sphere B has a radius of 60 centimeter. Calculate the ratio of their surface area in the form of 1 to n. Okay, meaning we reduce 1 to n. What it means is that we're going to reduce it to the lowest. The smallest one will be 1. Why? Because we're going to divide both sides by the ratio, value of the smallest one. So in this case, they are not talking about the ratio of their volumes, right? They are talking about their surface area. So what will be the surface area of a sphere in this regard? What will be the surface area? Pi r square, right? We use pi r square. So if we find the area of this as pi r square, the surface area. Okay, if we calculate one surface of the sphere, the surface area to be pi r square, then we say the value pi times 8 square. 8 square is 64 times pi. We get an answer, right? 8 square times pi. 8 square pi times pi. And then this is 60 square. 60 square times pi. 60 square multiplied by pi. Right? So we get an answer, then we do a ratio of 1 to n. We do a ratio of 1 to n. Pi times 8 square. You get 200, approximately 201. So we get approximately 201 for 8 square. For 60 square, what do you get? What's the surface area? Pi times 60 square, what do we get? Remember, we put a ratio. So what do we get? 804. Here we get approximately 804. So to get a ratio of 1 to n, meaning you use the smaller one to divide both sides. So what we do, you write 201 ratio 804. 201 ratio 804. So what you do, you divide here by 201 in order to get ratio 1, right? You divide here by 201, and then you divide this right side by same 201. Okay? You divide both sides by, you know why? Because we want to reduce this one to ratio 1. Okay? So if we say this divide by this 201 divided by 201, you get 1. Remember, they say it should be in ratio 1 to n. N will be any number you get if you've done that. So you already got this ratio 1. So you say ratio 1 to, when you divide this, you get 4. You get 4. 804 divided by 201, you get ratio 1 to n. If they ask you what's the value of n equal to 4. If they ask you what's the value of n equal to 4 in this regard. So you see, these problems like this will appear in your exam paper, and you should be able to handle them. You should be able to tackle them, okay? You should be able to tackle any of these type of problems. So with this, I think we've done justice to the part called the sphere and hemisphere. And another question they can ask you here, they can twist it like this. They may not be talking about the surface area. They may be talking about the volume of the sphere and find the same ratio 1 to n. So what you need to do here is just to say, for volume of the sphere is 4 over 3 times pi r cube. So you get the value here. You also get the value here. You divide both sides by the smaller one. You divide both sides by the smaller. You divide both sides by the smaller one. Once you do that, you get 1 to whatever number that's it intended for. So with this, we come to this aspect of the sphere, and I hope any spherical question in the exam you'll be able to attempt. You'll be able to do it, whether it's hemisphere, whether it's sphere, you should be able to do it. Now we move to the other part, which is called the pyramid. The pyramid. There are also different types of pyramid. Probably we might list them before we progress, okay? And then we'll come back to solving questions. We have different, just like the way we have different types of prism, we also have different types of pyramid, okay? We have different types of pyramid. We have a square-based pyramid, okay? So if we want to list them, like this one we have is a square-based pyramid. See, this one we've drawn here is a square-based pyramid. We have a square-based pyramid. We have hexagonal base pyramid, we have rectangular base pyramid, we have triangular base pyramid, and so on and so forth. Okay, we have rectangular base pyramid, and so on and so forth. So we have different types of pyramid. So I hope we know. So when you ask to calculate the volume of the pyramid, you must calculate the area of the base. If the base is a square, find the area of square multiplied by the perpendicular height in order to get the volume of a pyramid. So when you're dealing with pyramid, you must look at the base. You have to find the area of whichever base it is. If the base is a square, find the area of a square. If the base is a rectangle, find the area of a rectangle. If the base is a triangle, find the area of triangle. If the base is a trapezium, find the area of trapezium. After you've done that, then you will multiply, from the center of the base with broken lines. From the center of the base with broken lines, you get the height to the peak or to the apex of the pyramid. To the apex of the pyramid. Okay, we have pyramids in Egypt. You know the granite pyramid. You've heard of this. In Kano, Nigeria, we used to have the granite pyramid. And when Africa was based on agriculture, we were saving rice in pyramid. Even last 2022, they saved rice in pyramid, granite in pyramid. So pyramids were used to save food, agro-food produce for future uses. Okay, so we practically need to know what a pyramid is, and this is what we have shown. We say we have hexagonal base, so you have to find the area of hexagon. You know, you can divide the hexagon into triangle. We did that when we were looking at prism last time, hexagonal prism. So in part 2 of pyramid of mensuration, when we were looking at part 2 of mensuration, we looked at hexagonal prism. And then we show how to calculate the area of a hexagon. When the base is a hexagon, it can be divided into 6 triangles, right? If it's a hexagon, the base is a hexagon. Hexagon is a 6-sided polygon. It's a 6-sided polygon. For example, if it's hexagon, the shape would probably look like something like this. For example, something like this. Okay? It's a 6-sided polygon. A 6-sided polygon is called hexagon. So when you have hexagonal pyramid, you have to find this base area of this hexagon. You have to find the base area. Then before you can calculate the volume of the pyramid. Before you can calculate the volume of the pyramid. So you have to find this base area. And how do we find the base area if it's hexagon? If the base is hexagon, how do you find the area of the hexagon? We showed that in part 2 of our video. We did that in part 2 of our video, and we said we can divide this into 6 triangles, right? We said we can divide this into 6 triangles. And then we find the area of one triangle, and we multiply the answer by 6, right? We find the area of one triangle. All the triangles are equal. 1, 2, 3, 4, 5, 6. All the triangles are equal. So we need to know the length from here to here and the height. We only need to know this base and the height from here to here. That's it. So once we know these 2 values, we'll be able to calculate the area of one triangle, multiply the answer by 6. Then we get the area of the base of the hexagonal pyramid. Once you get the area of the base of the hexagonal pyramid, you know all of this will be taken to a peak. Let's say here is the apex of the pyramid. So all of them will be taken to the apex. Okay, so all of them, let's say here is the apex of the pyramid. All of them will come here, maybe with broken lines. All of them will meet at this place. So this is a hexagonal pyramid, an example of a hexagonal pyramid. Example of a hexagonal pyramid. An example of a hexagonal pyramid. Okay, from the height we start from this center here to to this place. Okay. So once you calculate the base area, once we find the base area, then we multiply by the height in order to get the volume of the pyramid. We multiply by this height in order to get the volume. So we'll give you the formula. We say the volume of any pyramid is 1 all over 3 multiplied by the base area. Whatever the base is, you have to find the area of that base first. If the base is a hexagon, you have to find the area of this hexagon. I said to find the area of this hexagon can be divided into 6 triangles. So find the area of one triangle, multiply by 6, you get the area of this hexagon. And then you multiply by this height, you get the volume of this pyramid, divide by 3. So it's always 1 all over 3. Okay, as the formula connotes. So for this case, let's say for example, if we have a rectangular pyramid. You can have a rectangle and they all meet at a point. Let's say if I have a rectangle here, we can have a rectangle. This will form a rectangular pyramid because all of this will meet at an apex. Okay, all this one will meet here. This is a rectangular pyramid. Okay, this is a rectangular pyramid. Okay, so whatever it is, it has same formula. 1 over 3 times the base area times the height. Now let's take a look at the question. Since we've shown the different types of pyramid that we have. We said you have a square base pyramid, you have a rectangular pyramid, you have a hexagonal base pyramid, you even have a pentagonal pyramid, you have a heptagonal pyramid, you have octagonal pyramid. So you can use the polygon names to form all the pyramid. You even can have a triangular base pyramid. Probably we may call that a prism if it becomes a triangular base pyramid. Anyway, it becomes a prism. Okay, now let's take a look at this first question. Question number 1. And we say a rectangular base pyramid has a perpendicular height of 5 centimeters and a base dimension as shown. Calculate the volume of the pyramid. Sometimes they also ask us to calculate the surface area of each of the face of the pyramid. Okay, we're going to look at that. So it says a rectangular base. You see, this is a rectangular base pyramid. Why is it a rectangular base pyramid? Because the length of this base is 7 and the width is 3. They are not equal. If this length and the width are 3, it will be a square base pyramid. So the base is a rectangle because the length is 7 and the width is 3 centimeters. The width is 3 centimeters and the length is 7 centimeters. So it's a rectangle. So this is a rectangular base pyramid. The height is 5. So they've given us the height. So the volume, we extract the volume formula for pyramid, for a rectangular base pyramid. For any pyramid, all types of pyramid, this is the formula we're going to use to calculate the volume. 1 over 3 times the base area. So we're going to first of all calculate the base area before we go on the volume. You have to calculate the base area of the pyramid before you do the volume. Okay? You cannot just jump into the volume if you don't accept the question where I had to just give you the area. If the question has given you the area, then you can jump into it. You can jump into calculating the volume. So right now, before we can progress, we have to calculate the area of the rectangle. Area of the rectangle. So because the base is a rectangle, the base of this pyramid is a rectangle, hence we have to calculate the area of the area of the rectangle. So area of the rectangle is length times width. Since the area of the rectangle is length times width, why are we calculating area of rectangle? Because it is 7 times 3. 7 times 3 length times width, which is 7 times 3, and it gives us 21 centimeters square. 21 centimeters square. So this is our base area for this pyramid, 21 centimeters square. Now, having found the base area of the pyramid, the next thing to do is to calculate the volume. Volume is 1 over 3. 1 over 3 multiplied by the area. So I will just say 1 over 3 times A, which is the area of the base, whatever base it is. You have to calculate the area of that base first, times height. times height. So this is the formula for volume of pyramid. So having done that, the next thing to do is to substitute to this formula. So this becomes 1 over 3 multiplied by the area which we've got it, which is 21. Area which is 21, you say times 21 times the height. Remember the question says the height of the pyramid is 5. Look at it here. The height of the pyramid is 5. It said the height is 5. So we're going to multiply by 5 as the height of the pyramid. So we multiply by 5 and we get our result. We get our result. So 1 over 3 times 21, we're going to get 7. Because 3 we cancel, 3 goes into 21. 3 goes into 31. We get, 3 goes into 21, we get 7. 7 multiplied by 5, we get 35. Right? We get 35. So most of the times, sometimes, you don't need a calculator. You just need to know how to figure out things. Okay, so the volume will be 35 centimeter cube. Since it's volume, you must put cube. Okay, sometimes you forget to put the units, you get less marks. Okay, centimeter cube, 35 centimeter cube. So this is the volume of this pyramid because it's a rectangular base pyramid. Now let's find another question. Question number 2 with a square base pyramid. No, this is also a rectangular base pyramid. 5 and 4 is a rectangle. If you look at the base of this Ringo Shoko, we're going to do more, right? We're going to do more. We're going to look at different pyramids. Okay, we're going to look at maybe hexagonal base pyramid, and we're going to solve a question on that. We're going to solve a question on that. Okay, so let's quickly take a look at that and see how that is useful to us. Is that okay? Now remember we say part 5 we'll be looking at cone. We're going to deal decisively with the cone, and then we end the mensuration with 5 videos. Okay, now let's take a look. It says find the volume of this pyramid, and it's similar to what we've done. As similar with what we've done. You see this place is showing you angle 90. Okay, so it's all angle 90. So the height is 16. The height has been given to us, right? And the length is 5 centimeter, and the width is this. And we said the volume of pyramid, just like we've highlighted in the first example, we say it's 1 over 3. The volume is 1 over 3 times the base area. So I'll just say times A. But whatever area it is, you have to calculate the area of that base. Okay, if the base is a hexagon, you have to find the area of a hexagon. If the base is a trapezium, if this base is a trapezium, you have to find the area of the trapezium first. If this base of this pyramid, if it's a square, you have to find the area of a square first. Okay, if the base is a rectangle, you have to find the area of a rectangle. If it's a pentagon, you have to find the area of a pentagon. Okay, so at every point in time, you have to find the area of the base of the pyramid. After you found the area of the base of the pyramid, before you can calculate the volume of the pyramid. Now, the volume of the pyramid in this regard is equal to 1 over 3 multiplied by the area. Now, like we said, the area in this regard is just length times width. 5 times 4, which is 20, right? So the area is length times width, which is 5 times 4, which is 20. 5 times 4, which is 20. So we already have our area to be 20 centimeters square, and then we bring the area into the formula of the volume. We bring the area value into the formula of the volume and find the volume of the pyramid, of this rectangular base pyramid. So I bring the 20 into this place. We say times 20 centimeters square times the height. What's the height? The height is 16. The height, actually, this place is from the center, okay? It's sometimes because of the drawing. It's always from the center up to this place. Okay, so times 16, which is the height. Okay, so if we key this into a calculator, we're going to get the volume, absolute volume for the pyramid, for this rectangular base pyramid. So if you key this into a calculator to 3 significant figure, you're going to get 107 centimeter cube. 106 point whatever. So we can write here 106.7, 106.666. Okay, 106. So we can say 106.7. But to 3 significant figure, we get 107, right? to 3 significant figures, we get 107 centimeter cube as the volume of this pyramid. Okay, so this is how it goes. The volume of pyramid is easy, but now there's something we need to look at. Not only the volume of the pyramid, there's something else we need to look at. What is the surface area? What's the surface area of the faces? We already know the area of the base. What's the area of this face? The area of the face on this side. The area of the face on this side. The area of the face on this side. There are 4 faces. Since it's a rectangle, 2 are equal. These 2, since if it's a square, all the faces that are standing and meet at a point, they will be equal. For example, let's do the spread. Since this is a rectangle, this is a rectangle. Let me show you the face. As it's standing, let's do the net. You've heard of net, right? Every 3D shape, we can break it down into net. Yes or yes? So every 3D shape, we can break them down into net. Now let's take a look at the net of this. So this one, if we break it to net, the shape will look like this. Absolutely and obviously. The shape will look like this. You have this face. You have this face on this other side. You have this face and this face on this other side. Okay, these 2 faces are equal, regardless of my drawing. This one and this are equal. You know why? Because the length here is same as the length here. So the face here and the face here, they're equal. Okay, they could be coming from this face and the other face here that stand to form the pyramid. Now there's another face that are also equal. Here is 4 centimeters. Here is 4. Okay, and here is 4. Okay, and remember the height is 16. So we can calculate the area of this face. This height is 16, h. So I put h here equal to 16. Remember the height is 16. 1/6. The height is 16. The height means from here all the way to the top. This is the height. Okay, this is the height. Same here. All of them, the height is same. Now let's take a look at with a different designation, a different modeling. Let's take a look at this face. Now this face, and this face, they are same. This face and this particular face we're drawing now, and this one we're about to draw, this one, they are same. Okay? Why is that? Why is that? Why are they same? Because they have the same length. See, this length and this length, they are same, which is 5 centimeters. Remember, this length is 5 centimeters. Okay, and this one will also be 5 centimeters. And then, therefore, the height, h, is also 16. Remember that. You know, they are all meeting at a point, which is the peak or the apex of the pyramid. So here is also 16, the height. Now, calculate another questions that comes in the exam. Question number 3. For this, you know, we are diagnostically solving this one. We are treating this cancer. Okay, let's assume this is a cancer. We want to solve this cancerous problem. Now, the question, you know, in most of the exams, the questions in textbooks, they only teach you the volume of the pyramid. Now, you have to pay attention to what we are telling you now. In most of the IGCSE exam paper, they ask you to calculate the surface area of each of the face and calculate the total surface area of the pyramid. So, before we can do that, question number 3, total surface area. Question number 3, they're asking us to calculate the total surface area of the pyramid. So, to calculate, so if you find in the exam, you'll be wondering, we were not taught, you know, we only learned how to do the volume of the pyramid. How do you do the total surface area of the pyramid? So here you pay attention, because even if you check your textbooks, you see most of the books do not refer to this. Do not refer to this. They just treat how to calculate the volume of the pyramid. Okay? So here we are looking at how to calculate the total surface area. Even before the total surface area, they can ask you to calculate the area of each of the faces. Okay, that could be question A, Roman figure A, or question 3A, area of each face, and then B is total surface area. B is total surface area. So here is area of each face. See, I put area each. A each. That's the area of each face. So now let's do that. Two faces are same because it's a rectangle. If it's a square, all the four faces will be same. You just need to do the area of one face multiply by 4. If it's a square, you know why? Because a square, the length here is same as the one here, same as the one here, same as the one here. So you just need to do the area of one face multiply by 4 to get all the faces. Now, in total, we have 5 faces. This face, this face, this face, this face, which makes it 4, plus the base area, which makes it 5. So a pyramid, a rectangular pyramid, has 5 faces. Now let's calculate the area of the two that are same. So area of the left and right. So the green one, the green color, left and right. So area left and right. And then we have top and bottom. Left, right. Okay, I will just do only area of left is equal to, then we multiply the answer by 2. Area of left is half times base times height, right? Because it's a triangle. Half times base times height. Why? Because it's a triangle, right? So you calculate the area of the triangle, which is half times the base. The base is 4. Half times the base, which is 4, times the height, which is 16. Times the height, which is 16. So you can say half of 16 is 8. 8 times 4 will be 32, right? So we get 32 centimeters squared. That's the area of one of this face. 32 centimeters squared is the area of this face alone. So let me write it. And then here, the area of this face alone is 32. Area of this face alone is 32. Similarly, 32 centimeters squared. Similarly, the area of this other face, because they are equal, area of this face will also be equal to 32 centimeters squared. Okay? Which is 64, because they are equal. So you see, you solve one, you've got a solution to 2. Now, you're going to find the area of top and bottom. So we can do it here. We can do that here. Area of top, bottom. Area, top, and bottom. So it's same formula, half base times height, half times the base, multiplied by the height. Half times base times height. Half times base times height. So after we've done that, the next thing is to substitute the values into our formula. So half is 1 over 2 multiplied by the base. In this regard, the base is 5. The base is 5. So we say times 5 times 16 because the height is same. The height is same for all of them. So times 16. Have we done that? Well, this will give us 40. Okay, this will give us 40. 40. So we have area equal to 40 centimeters squared for this face. Now, if you come here, you put the value. Okay, because they say calculate the area of each face. So we are calculating the area of each face, and then the B part, the total surface area. So here, this face down is 40. So I write A equal to 40 for this face. A equal to 40 centimeters squared. A equal to 40 centimeters squared. Okay, and then also here we write A also equal to 40 because they are equal. Because they are equal. Area of this face is equal to 40. And remember the base area. We've done the base area even when we started, before we calculated the volume. Remember, you have to do this base area in order to get the volume. Remember, we got the base area to be 20 centimeters squared. Length times width, that's 5 times 4 because it's a rectangle. So it was 20 centimeters squared. Now, the total surface area is for us to add everything together. Okay? is for us to add everything together. So the total surface area is to say 32 plus 32, which is 64, 40 plus 40, which is 80, 80 plus 64 plus 20. So I have TSA, total surface area of the pyramid, is equal to 40 plus 40, 40 plus 40 plus 20, that's 100. Okay, so if you add this, you get 100. Then plus 32 plus 32, which is 164, right? Plus 32 plus 32. So the total surface area will be 164. Okay, 164. So this is what it is, and this is the game. This is how they will play with you. Okay, so if you know it, how to solve this kind of problem, then regarding pyramid, you're done. Because its total surface area is area, the unit will be centimeter square, not volume. If it's volume, you say centimeter cube. Okay, so this is the biggest game they can play with you. This is the biggest play they can play with you in this regard. So this is what we want you to understand for this part of this lesson, that you have to understand how to calculate the total surface area of a pyramid, and we've explained the different types of pyramid. We say you have rectangular base pyramid, square base pyramid, rectangular base pyramid, hexagonal base pyramid, octagonal base pyramid, heptagonal base pyramid, nonagonal base pyramid, decagonal base pyramid. So whatever pyramid it is, you have to find the base area first before you can calculate the volume. We say the volume is 1/3 times the base area multiplied by the height. Once you do that, you get the volume of the pyramid. Now, for the total surface area, you have to break the pyramid into a net. Once you break it down into a net, it's easier for you to see it accurately and correctly. And then you'll be able to calculate the surface area of each of the face. All these faces are triangle. So you find the area of each of the triangle and find the area of the base. You add all of them together, you get the total surface area. So that's for pyramid, okay? Like what we've looked at in the case of a sphere, we've demonstrated a sphere, and we've showed you that a sphere is a 3D shape, which means it's not just a circle. It's not just a circle, but we just use circle to model it. We use circle to model it because there's no other better way to model it. It's a 3D shape. We've studied sphere and hemisphere, and we say the volume of a sphere is 4/3 pi r cube. And the volume of a hemisphere is just to divide that 4/3 pi r cube by 2, you're going to get 2/3 pi r cube. And after we've done that, we said questions can come for surface area. You just use pi r squared for the surface area. Is that okay? So that's that for today's class. And we hope to see in part 5, which is the last part of this lecture, which will take a holistic look at a cone. We're going to dig into cone, how to change area of a sector, to change the sector into a cone, and the gaming, interwovenness between a cone and a sector of a circle. We're going to delve into this. There are a lot of secrets in that place that we're going to bring out, and that are always hindrance to students' success in the exam. So thank you for joining us, and we ask you to subscribe to our YouTube channel for more videos. Thank you.